In this video, we are going to use the elimination method to solve a system of equations, starting off with two variables. So on this first example, we have 5x plus 8y equals negative 24. And then the second equation is 4x minus 8y equals negative 48. What you are wanting to do is to be able to add these two equations together and eliminate one of your variables, either your x's or your y's. So you'll notice if I add my x's together, I have 5x plus 4x, which is 9x. But look what happens when you add your y's together. You have 8y plus a negative 8y, or in other words, 8y minus 8y. So those actually will eliminate. So that's exactly how you would want this problem to set up. Because if that is the case, and you're adding two of them together and one of them eliminates, that's what you're going to want to do. So I have 5x plus 4x, which gives me 9x. The 8y minus the 8y cancels. And then I have negative 24 minus 48, which gives me negative 72. Now I can solve, so since my y's eliminated, now I'm just left with the statement or the equation 9x equals negative 72. So I can solve this for x. So I'm going to divide both sides by that 9. So I have x equals negative 72 divided by positive 9 gives me negative 8. Once you have solved for one of the variables, now I know that x equals negative 8. I can take that solution back to either one of these top two equations and replace the x with that with that negative 8 and solve for y. So let's just put it in that top one. So I'll have 5, replace the x with negative 8, plus 8y equals negative 24. So let's see, 5 times negative 8 gives me negative 40, plus 8y equals negative 24. Solving for y, so I'm going to add the 40. So that cancels. So now I have 8y equals negative 24 plus 40, which gives me 16, and then divide by 8. So what are you left with here? When you divide both sides by that 8, you're going to have y equals 2. So what you have found is the point at which these two equations, if I graphed them, would cross at on the on the graph. So I have the x coordinate and the y coordinate. So here's my x. When you solve for x, you got negative 8. Then you plug that in and it told you that y was 2. So that would be your solution. When you enter these, you are going to have to enter that as that ordered pair. All right, on this next example, I have 9x plus 2y equals negative 11, and 2x minus y equals negative 1. So unlike the last one, when I add these together, neither the x nor the y would eliminate, right? If you added these together, you would have an 11x, and then you would have a 1y. So what I need to do, we're going to use the rule that says you can do absolutely anything you want to an equation as long as you do it to both sides. So when I am looking at these equations, what I want to do is multiply one of them by a number that will help me eliminate the x's or the y's. So the easiest thing to look for would be to look for a variable that has a 1 or a negative 1 in front of it, because it's easy to turn those numbers into whatever we want them to be. So look at this negative y. I want to multiply it by something that's going to eliminate a positive 2y. So what eliminates positive 2? The opposite of it, which would be negative 2. So what I'm going to do here is multiply this entire equation by what's going to make this y have a negative 2 in front of it. Well, if it's got a negative 1 in front of it now, if I multiply that by 2, that's going to make this turn into a negative 2 because I'm going to distribute, and I've also got to multiply the other side by, 2. Sorry about that. So I've also got to multiply the other side by 2 because that's what keeps the equation balanced, doing one thing to both sides. So let's see what that gives me. I have 2 times 2x, which gives me 4x. Then I've got 2 times negative y. That's what's going to give me the negative 2y equals, on the right side, I've got 2 times negative 1, which gives me negative 2. So now that you've done that, this second equation and that bottom equation are actually equal. They're the same equation because I did the same thing to both sides. So it's almost like you can just forget about that equation in the middle. Now I can add my top equation to my new equation and my y's will eliminate. So that's what I'm going to do. 9x plus 4x gives me 13x. 2y minus 2y, which means my y's eliminate, equals negative 11 minus 2, which gives me negative 13. So now I've got an equation that I can solve for x, so I'm just going to divide both sides by that 13, and I get x equals negative 1. And just like the previous example, once I solve for x, I can take that x all the way back up to this top equation, and I'm going to replace that x with the negative 1. So I've got 9 times negative 1 plus 2y equals negative 11. 9 times negative 1 gives me negative 9 plus 2y equals negative 11. So now I'm trying to get the y by itself. I've already got the x by itself. I know what x is. Now I'm trying to solve for y. So I'm going to add that 9 to both sides. So now I've got 2y equals negative 11 plus 9 gives me negative 2. So then I'll divide both sides by 2. So now I know that y equals negative 2 over 2 gives me negative 1. And again, you enter your answer as an ordered pair, the x coordinate and then the y coordinate. So my x coordinate is negative 1 and my y coordinate is negative 1. So when you enter the solution, again, you want to enter that as an ordered pair. So you can either use the ordered pair that's in the toolbox, or you can just use the parentheses that are on your keyboard. So let's see, my x is negative 1 and my y is negative 1. All right, last system that we're going to solve that only has 2 variables. So the first thing I notice on this problem, 8x minus 9y equals 24.5, and 7y minus 2x equals negative 8.5, is that second equation, my variables are not in the right order. You want your x's in one column, your y's in the next column, equals then your constant, which is your plain number, to be on the other side of the equal sign. So when I write this one out, I'm going to have 8x minus 9y equals 24.5. When I write that second equation, I'm going to put the x in front, so I've got negative 2x plus 7y equals negative 8.5. Okay, so you want your x's in one column and then your y's. So I noticed that like the last problem, I'm going to actually have to mess with one of these equations so that I can eliminate a variable. Let's look at the x's in this case. The top one is an 8x. The second equation is a negative 2x. If I multiply this second equation by positive 4, look what it's going to do to the x. It's going to turn it into negative 8. So when I add that to the top equation, it will eliminate the x's. So that's what I'm going to want to do. Multiply both sides of that second equation by positive 4. So when I do that, 4 times negative 2 gives me negative 8x. 4 times positive 7 gives me positive 28y equals negative 8.5 times 4, which gives me negative 34. Whoops. So now I can kind of forget about this middle equation and add the top equation to the bottom equation, because here I have 8x minus 8x, so my x's will eliminate. Then I've got negative 9 plus 28, which gives me 19y equals, I've got 24.5 minus 34, which gives me negative 9.5. So now I can solve this one for y by dividing both sides by 19. So now I've got y equals negative 9.5 divided by 19, which gives me negative 0.5. So remember what you're solving for. You're going to create this ordered pair with your x and your y, and you just found that your y is negative 0.5. So that's going to be the second coordinate. So I'm going to use this negative 0.5 and replace that y in the top equation. So when I do that, I have 8x minus 9 times negative 0.5 equals 24.5. So let's see, I'm going to have 8x, and I've got negative 9 times negative 0.5, which gives me positive 4.5 equals 24.5. So solving for x, right? X is what I'm missing. So I'm going to subtract the 4.5. So now I have 8x equals 24.5 minus 4.5, which gives me 20, and then divide that by 8. So I'm going to have x equals 20 divided by 8, which gives me 2.5. So the x coordinate is 2.5. So when you enter this, again, type it as an ordered pair, 2.5 for the x, and then negative 0.5 for the y.